Hello, I'm back. I'm gonna start doing this in the morning now. I'm changing my sleep schedule. I feel more productive if I do this. Also, my brain works in the morning, which is crazy. Anyways, where did I last end off of? I still do all these. Count complete tree nodes. Contains duplicates. It's okay, I'll come back. I'm gonna try to do 2 hours every day. Let me set realistic. I'm at 51. I think I want to try to do like 10 a day. Let me get our stuff back. Let's try to do each one every day. Yeah, let's get right into it. Oh, my voice. Unique for alright, let's just do this one really quick. So what we really want to do is make sure that it's one apart. Then it's good. Two, three, four. So I think we want to store the first number. And then first num is equal to false. And then we want to store this num. And then if that is not true, then our range is int to string. I don't think you can just concatenate string. Dot to string, okay. I'll take concat strings. Oh, you can just use plus? Alright. So this to string, we got nums at nums at I points to, sorry, to string first num goes to plus to string last num. That's only if first num does not equal last num, right? Because here it has to point to 0 to 2 for the 5, but this is the last one. So else first num is equal to last num, then we can do ranges dot push back first num. To string. So here first num is equal to last num 0, and then the difference is not equal to 1, so where are we going to push it back? Yes. I think this is always true for the first number. Because let's say we do 2 to 4 minus 1 is first num. Yeah, so this is always true. Only if first num. We should also set last num here. Just in case it's like this 0 or like this 6. If not, okay, so let's run for example. 0 is first num, that's true. Then this is false forever. So first num is 1, first num is 0, last num is 0. Cool, that's fine. Next, this is false. Else if, oh, I need to make this true again. Else if num's plus 1, so I'm at 1 now. My minus num's I, so 2 minus 1, and last num is equal to num's at I, so last num is equal to 1 now. That doesn't work because what if it's only 2? Like what if this is 2? I think I'm always going to have to start at -1. This should always be true to first run, so that's fine. And we can catch this one if num's at I minus num's at. So this one now, so num's at 1 is always 1 ahead. Since this one will always catch the first one, this won't error ever. But this needs to be plus 1 now. So 0 if first num, that catches that. So we move here. 1, num's at 1, minus num's minus 1 is equal to 1. Last num's is equal to 1, that's fine. Go back here, this still false. 2 minus 1 is equal to 1, that's true, so last number is 2. You go here, it's still false. Now this is 4 minus 2 does not equal 1, so this else happens. If first num does not equal last num, 2 does not equal 0, we push back, else we would just push the number. And then first num is equal to true, and we have to reset our first nums and last nums. So right now we're at 4, so first num we're at first num. If we do I minus minus, then we go back 1 in the queue. So then we'll go back to is first num. So we're back at 4 because it's good plus plus here. This is true now though, so ish first num is false. Then we got 4 and 5, that's good. Then this is false again, we go here, it's 5 now. 5 minus 4 is 1, so this is true. So now we have first num is 4, last num is 5. Then you go back here, 7 minus 5, that's not true. We go through this else, push back that range. First num is true again. You go I minus minus on 7. 7 is equal 7. Then we go here. Seven minus 7. Yeah, wait, sorry. We're on the last index, so we have 7. Here we have 7 and 7. And we go through here, but then that'll end the loop, so we actually can't catch the last one. And I does not equal nums dot size. So that should trigger first, and that won't error, so then it'll push back the last one. And then we return ranges. Alright, cool. Looks like that works. Alright. Looks like we always forget to do if nums is equal to nothing. Nums is equal to -1. I is equal to 0. I less than nums dot size plus 1. I plus plus is first num. It should be just -1. And this is also -1. Why is that arrowing? This is an integer, should be able to do that. -1, -1. You go past. This is false now. -1, then it tries to run one more time, but this is false now, so it should just run into here, which this should be safe. Else is first num equal true if nums dot size does not equal I. There you go. Bruh. Okay, have to use longs, I guess. Why is that even a test case? Okay. Oh, there it is. Okay. I guess I need a special case for if it's really big. I think if it's a big num minus a small num, it's fine. Why does he have this? I feel like this doesn't add anything to the question. vec long. Vec long. I don't have access to that one. Reinterpret cast. Unlike static cast. Can I see example of reinterpret cast? The pointer doubled. Vector long for nums. That's password reference, so we need to give it the pointer. Oh wait, value of P2, because P2. Sorry, is ST a pointer? I don't know what S1. Sorry, this. Vector into vector long is not allowed. Bruh. Okay, if that happens, then we'll sorry, I want to do this first. So then big it's just equal to false. I should skip that. What? How does that affect that both of those? That doesn't make any sense. We'll just do this. Bruh. Alright, whatever. If it works, it works. I don't care. This is a C++ issue. Alright. How long did that one take? Oh, 30 minutes. Oh my god. That actually suck. Alright, if I do 4 a day, I guess, then I'll be done. Have to do 750 still. It'd take me half a year. Bruh. Maybe I should switch languages sometime. I like C++ though. Okay. Well, whatever. Power of 2. Just square root it, and then if it's not decimal and pow and 0.5 remainder 2 is equal to 0, then return true. Oh, you can't remainder powers? Oh, that's interesting, actually. We'll just cast this to it then. Input n is equal to 1. N is equal to 16. n is equal to 3. 16 square. It's like 3 square rooted. Oh, actually that would introduce too much error. Okay, new idea. We can just do log. Log 2. So like 16 log 2 log 2 16 is 4. Because that should give me n is 16. That gives me the power 4. So if whatever log 2 is equal to pow 2, then pow 2 log C++. How to log 2 log 2 of n is equal to pow of n pow equal to pow please. Floor. So I should log into floor. Is this good? Yeah. Okay. All I have to be scared of is runtime errors now. Yay! Yippee! I just forgot I didn't pass the last one. Submit. Yippee. See, this one's... Okay, I should always read the constraints. Oh my goodness. I guess I should do this. So I want the stack to act like a queue. I have 2 stacks. So let's say I have my first number, push Okay, so like, let's say I have this. So then we can have our stack should look like that. So I'm guessing I push 1. What? So my queue here is, how do I draw on this? Is 1, 2. So this is where, this is my front. This is my front. This is my back. So if I peek, I should see this one. Okay, well, let's say I have a stack. I'm gonna push, and this is my front, and this is my back. How do I make a queue? I have to look at my back. Leftmost is front of queue. Return 1, return 1, is 2. I mean, what I could do is pop all the way till I get here, but then that's N. So maybe when I push, I should just rearrange it with a stack, like a stack. So then I will push 1, right? And then the other one, it's kind of just chilling there, actually. How about one stack always has the front, and then the other one I don't care about. So this is my front stack, and this is my back stack. So whatever else I push, I can push onto here, but this is always my front. But then once I pop this, then this needs to be the first one here. Which it won't be anymore. This is so dumb. I don't know how to do that. I mean, no. I mean, I'm pretty much here. Back, front, back. Maybe my first stack is a stack of stacks. No, that doesn't make sense. I don't like this question. I'm gonna come back to it later. Okay. Yeah, let's make a stack. don't think this is helpful. Two, three. Okay, well, there's this bottom follow-up said, could you do it in O of n time and O of 1 space? So that means you can do it in place for sure. What if I send an iterator pointer to the back and then go backwards from there? It's not like it can go backwards. It's not doubly. It's a singly linked list. And I don't want to make a duplicate. Iterators equal to head. Iterators next does not equal null pointer. Oh, the node val is only 0 to 9. It's an interesting constraint to have. Okay, what I'm worried about right now is like the case that it goes to 1 to 2 to 3 to 4, for example, and this like keeps on pointing to 4. How do you know it ends? Right, like this is a palindrome, but this is what we need to compare with this, right? But how do we know that, you know, we start comparing it here opposed to here opposed to here? Here it comes out. Why don't we remove duplicates? Then we don't have to worry about this. Yeah, but that's true. But then this could exist, and then that's. What if we make it backwards? What if we reverse the list? With my reverse list reverse list technique. But the problem with this is this one reverses the original list of head, because I'm dumb. And I'm like, you don't need head anymore. You can just reverse it, and then that's the new one. How do I make a copy of? How to make a copy of linked list C++? Okay, I think we would need to copy it, which is going to take a while because we have to make new nodes for every. Yeah, I don't think that's the solution. Other thing I was thinking, you can use the sum, but then let's say you have something like this. Not a palindrome, but I would do like 1 plus 3 minus 2 plus 2, and that just doesn't work. I could always just go through it and then Alright, I guess I could do that. Oh, I forgot to do it if... Okay. Oh, I'm faster than most people. It's just very inefficient to change it to a list. I want to do it in place. It's okay. I don't know how to yet, so I should just do what I can. Alright. 234. Valid anagram. What is an anagram? I am just going to can I assume that they're equal? Oh, I cannot. Yeah, I think for this one it actually works if I mean, you could use a hash map, but I think if you add up all the numbers, it should also work most the time. Sorry, all the letters, right? Because they should all be the same. If one letter is slightly different, but if one letter is slightly different by one, and one letter is slightly different by another one, when is my something gonna work? I don't think ever. Like if one is M and one is P. One is M, one is P. Yeah, that doesn't work. Okay, so I can't use some. Is it always lowercase? Yep. Why don't I just hash each one? That way they won't equal each other. I don't know, something random. Then there won't just be a difference of one, there'll be a difference of something a lot, like, a bit bigger. I mean, it only needs to be 26 bigger, 26 bigger for it to work. Ah, now I'm cooking. 27, just to be safe. So then we can just add why is it green? Okay, whatever. Sum of s plus equal s at I char to int. Okay, just oh, okay. Times hash sum of t plus equal t at I times hash. And if sum of s plus sum of t return true, else return false. Does this work? What does this output? 70. I don't see how that could be possible. Yeah, that's interesting. It's also not correct. Sum of t sum. Let's do minus, so I'm at A right now. Lowercase a, so I should minus by 96. I think the numbers are getting too high. 96. 1 in 14. Whoa, why is this massive? I'm just wait, what? Sorry, I got a calculator. 1 plus 14 plus 1 plus 7 plus 18 plus 1 plus 13 is 55. How am I getting this massive number? Oh, it's because I didn't equal this to 0. Oh, why? Oh, I'm just stupid. Alright, thank you C++. I appreciate you so a lot. But I have the hash and everything. I have the hash and everything. The hash and the work. 1 and 2, 3 and 2, 128, 27. What if I pow it instead? By 2. Then it's unique. For real. What? Right, come on, code. Now you can do it. What? Alright, come on. Come on, code. Nice. Now it's unique. Submit. What is this? How is this equal? Let's do what if I power it by 3? Nice. Goes to a massive number, yes, but it doesn't matter. Oh my goodness. Okay, what if I power it by 4? Okay, it works if you power by 4. Yeah, we on top out here. I wonder, okay, I want to find out hash to make differences of one not exist. Multiply with the character index. Yeah, that would be unique for that string. But I want to hash it so that even the character indexes don't matter. Alright, well, I like my solution. They're probably like, the heck, you can't just do that. But it's okay, I just did. Sweet bad man. Alright. Shortest word distance. Oh, premium. Oh, also premium. Also premium. One, two, three. So DFS. And then we can keep it in a stack. This is a hard question, I feel like. You can go left, right, left. Or what if you go left, left, left? Or right, right, left. And right, right, right. That's more... It's a bit harder. Or we can just go till we reach null root and keep a list of previous nodes and then print it. I think that's easy. Yeah, I'm gonna do this last one. Void DFS. And then we'll have a vector of tree nodes. Prev nodes. If root is equal to null pointer or root dot left is equal null pointer and right is null pointer. Return. Okay, I'll range from 1 to 0, so actually can't equal null pointer. What's a vector of strings? So Alright, so if root is null pointer, then we're going to and then else we are going to explore the node. And the previous nodes would just be prev nodes is the current node. Dot push back. node at val. Now if we leave this local instead of pass by reference, then only this will update when after we do that. This will keep the previous nodes. Then we can do all paths push back node at val. And then if we go to the to do if prev nodes is just one, it should just give me one now. Alright, I think that's good. Let's see. What? I've been using pushback. Pushback vector string prev nodes dot pushback dot pushback. What? Oh, it's an int. Two strings plus two string. There we go. What do we get? What? It's already in there. Okay. We don't need to string this. It is already a string. Come on. No one can set me apart. baby, what up, nigga? Roots. Of 1, 2. I should have 1, 2, and 5, right? Oh, we don't have the current. We don't have the current temp string. What? Where did it go? It was right there. Oh. There you go. We are back here. Alright. I think that should cover everything. I think this will pass. Nice. Alright, that's the last one. I did 5 today. Which is kind of nothing, to be honest. But that's okay. 2, 5, 7. What are we on now? We did 5, 6. We did 6 more. Yay. Damn, easies are actually pretty hard. This is what I learned. 6 more. Add digits, ugly number. Let's see if I can find the easy one. Another easy one I can get away. You ensure your num repeatedly add all its digits until the result only has 1 digit. What? 38, 3 plus 8 is equal to 11. Okay. That's interesting. Okay. Alright. Temp sum is equal to temp num remainder 10. Temp num divided equal 10. So I get the 8, get the 3, and then it's equal to 0. So then that's it. So wow. Places we used to. Okay. Do while loop. Do temp num is equal to num. So temp num is equal to 38. While temp num does not equal 0. Does not equal 0 yet. Temp num plus temp sum plus equal temp num. So remainder 10. So that's 8. Then it's 3. Then it's 11. While temp num is less than 11 over 10 is still 11 over 10 is greater than 1, not 10. So 10 over 10 is still 1, still 2 digits. 9 over 10 will be 0 though. And return times sum. If it's 0, then temp num is 0 does not equal 0, 0 output 10. I forgot about casting, implicit casting. My bad. What? I don't understand. Temp num equals num, so equals 38. Temp num 38 is greater than 0. True. Temp num plus equal temp num. What? I'm confused. Why am I even using a temp num? I could just do normal num. I'm not gonna use this number after. $38. 3 plus 8 back up here. Num is equal to 11 now. Well, temp sum over 10 is greater than equal to 1. I don't get it. Okay, num is 38, does not equal num. 38 remainder 10 is 8. 38 over 10 is 3. Num does not equal 0. 3 does not equal 0. 3 remainder 10 is 3. That's 11. This is 0. This is it. 11 over 10 greater than equal 1. 1. It's still greater than or equal to 1, so we go here. Num is equal to temp sum. 11. No. Temp sum is equal to 0. Whoops. I messed up. We forgot to reset it. Can you do it in O of 1? Probably. Not going to though. Alright. I think this one was relatively easy. How would we do it in O of 1 though? Do you know the same patterns? 38 turns to... Maybe the answer to this is no. Okay, I'm done for real. This is my little brain wake up time, so I think it works. I've been woken up. Damn, I suck at LeetCode. What is this one? Oh no, this one. This one's so hard. I don't know. No. No. This one's so hard. Okay. Goodbye, everyone.